All right, 3.5 part 2. This one with the limit as x goes to infinity for the sine of x graph. If y'all think about what the sine of x graph, remember that's that wavy curve that starts at 0 and does this, down to -1, up to 1, down to -1, up to 1, and it does that forever and ever and ever. Well, then the y value doesn't approach a single number, so therefore then this limit would not exist, again, because this graph oscillates between -1 and 1 always. All right, so what if I took the sine of x divided by x, though? See, this numerator oscillates between -1 to 1, but the denominator is getting huge, like to a million, a trillion, a zillion. If I take any number between -1 to 1 and divide it by a zillion, isn't that getting really, really close to 0? And I hope that's what you're understanding that. So again, we know sine of x is between -1 and 1. If I divide all three of these by x, this is approaching 0. This is approaching 0. Therefore, that would have to approach 0. And that's actually called the squeeze theorem. See, the sine of x divided by x is actually squeezed between these two functions. If I start with that, we know sine of x is always between -1 and 1. Divide all three by x. And again, the limit of that one is 0. The limit of that one, again, as x goes to infinity, of this one on the right is also 0. Well, if these are both 0, then that is squeezed between the two, and therefore the limit would be 0. And this is a new flashcard for you guys to memorize. This is on your new Quizlet as well. So with the limit as x goes to infinity for the x to the third graph. If y'all did the arms, the end behavior from Algebra 2 and college algebra, this would be very helpful. So I also want the limit as x goes to negative infinity for this graph. So you're basically asking what's the end behavior. So the x to the third graph, if we think about it, does that right there, the little kind of that stretched out s. I'm hoping to have a graph of it. There we go. So here's the x to the third graph. Hopefully you were thinking that. So as x gets large in terms of the right side, this graph is going up forever, and that is positive infinity, increases without bound. As x goes to negative infinity, that's to this left side, as x is going all the way out here, -100, -1,000,000, -1,000. Well, those y values are also going way down negative very quickly to negative infinity. That ends lesson 3.5. I have made a note here on teach how to use oblique asymptotes for limit as x goes to infinity as well for number 5 in your homework. So if you guys in class tomorrow, please come in and somebody have me pull up their number 5, and I will teach you how to do the oblique asymptotes for the limit as x goes to infinity. Other than that, we'll see you tomorrow. Have a great day.